Hi everyone. Today we'll look at how to create a write-on animation using p5.js and a few other JavaScript libraries. As you can see on my screen, this is the effect we'll be creating today. We're going to get the outline of a font and draw a path over time. And we'll do this in 5 different stages. And here are these 5 different stages. First, we'll take a look at p5.js textToPoints method to get a text outline as a series of points. And then we'll try to draw a path using this point data. But you can see that we have some issues here because textToPoints method that p5.js provides us doesn't have a way to tell where each word ends or where each path segment ends and begins. So it'll all just be a single path. And you get this connecting line. They may look cool sometimes, but some other times we don't want to have that. So to solve this problem, we'll use opentype.js library. We can now get clean outline of each glyph and each subpath as well. With this clean path data, we're going to introduce another library called g.js so that we can resample these path data to equally distanced points. So it looks like we took a detour from p5.js textToPoints method to using opentype.js and g.js. But now the difference here is that we get outline data per subpath, so they are not connected. And finally, we use the data to create this write-on animation. This part is pretty simple. We just need to connect vertices with lines, and that's about it. So let's start from the beginning. I'll be using p5.js in the instance mode so that I can use other libraries installed from npm. I'm in my terminal and I'm on desktop. From here, I'll be using a template code downloaded from GitHub. I'll use git clone command and clone this repo, github.com/dizzycoder/p5-template-esm. And then I will clone to this directory, which I named write-on animation. After it's cloned, let's cd into this directory, cd write-on animation. And we can look at what kind of files have been cloned. And from here, if you're using a code editor like Visual Studio Code, then you can open this directory in it. Or in my case, I use NeoVim code editor from the terminal. So that's what I'll be using. But feel free to use any code editor you like to use. I'm inside the code editor, and when I look at the source folder, I have a single file called index.js. And here we have a very basic template code for a p5 sketch. And let's start a local server so that we can run this sketch. And to run a local server, if you're using the same template as I'm doing, and you'll need to open up another terminal window from the same directory and run npm run dev command. And it says it couldn't find the command. That's because I haven't installed the dependencies. So first I need to run npm I to install any dependencies that's included in this template. And once it's done, then we can run npm run dev to start the server. And my local server is running at this address. So I placed the browser right below my terminal window so that we can see both the code and the sketch at the same time. And we have a single circle at the center because of this ellipse function. And today we're interested in drawing text path. We'll need to add a font file to our project directory. In the project directory, let's create a new folder called public. The name has to be public because of how this bundler has been set up. So create a public folder right next to source directory. And in the public folder, you'll need to place a font file. And in this case, it will have to be OTF font format. There are mainly TTF and OTF font formats. We will be using OTF fonts only because I've noticed that when I use opentype.js to get outline path data, it didn't work quite well with TTF font. So make sure you find font, any font, but it would have to be OTF font format. And here I placed nanum square neo OTF regular.otf font file. You don't have to use the same font as I'm using. Just any OTF font file should do fine. And let's write some code. To load this font file to our p5 sketch, we'll need to use preload function. So it'll be font equals p.load font. And because we placed the font file in the public directory, we only need to write down the name of the file. You don't need to write public slash. It's all handled by the bundler in this case. And we haven't declared this variable called font, so let's do it right outside of preload, let font. And this is optional, but I'm gonna use this special comment so that I can get better code hint. So when you hover over this variable, it shows what type of variable it is, which is p5.font. Let's save our sketch and make sure there's no error on the console. Let's use this font object to get points from some text. And you can see textToPoints method takes a few different parameters, text string, X and Y position, and font size, and some options. So let's provide that. Text, X, Y, and font size, which I haven't created yet. So let me go up here, and text will be, let's just call it type, and X will be some default values. Font size will be something like 240 maybe. And this will return an array of points. So I will store in a variable called PTS, points. Let's first look at how this point array looks like by printing to the console. And here's an array of 324 different points. The points array is just an object, a bunch of points, X, Y, and alpha. Alpha isn't really important in our case, but we want to use X and Y positions. So I'm going to iterate over and draw some dots. Let's delete the ellipse. We don't need it anymore. And we'll iterate over points using PTS array dot for each. So for each point, I will draw ellipse at pt.x and pt.y location, and maybe 6,6 as a size. And then we get an error. PTS is not defined because I define PTS as a local variable within setup function. So draw could not access it. So let's move it up. Let PTS will be just a empty array at the start. Now save it, and we can see the result here. Let me move it a little bit so that it doesn't get in the way of our code by changing the X position. Something like that. And you can use optional parameter to this textToPoints method to decide how dense the sampling will be. I think the default is 0.1, but if you use something like 0.05 or bigger value, 0.15, then it gets denser. It samples more points along the outline. And how about we draw a path using these points? So instead of just drawing individual ellipses, I can use same point to draw vertex and then surround it with begin shape and end shape to draw as a path. Nothing happened. What about I set stroke color to be white? Well, it wasn't that. Oh, vertex only takes two parameter X and Y. So I need to delete this 6,6. And there you go. Let's disable fill. And we get a nice outline path. But like I said at the beginning, there's no way we can tell where T ends and where Y ends, so on and so forth, because our points array is just one-dimensional array. And there's no information whatsoever to tell us when to end this T shape and begin another Y shape, etc. That's why we need to use other libraries to do that. So let's open up another terminal window. Make sure you are in our project directory and run npm I opentype.js. And come back to our sketch, move to the top. Right after import p5, we will import opentype library. And now instead of loading our font file using p5 load font method, we will be using opentype.js library. And when you're loading external files using non-p5 functions or libraries, you can't really use preload function, unfortunately. We'll need to do this within setup. I'll paste a few lines of code, which I found from opentype.js library website. We first get buffer object and we parse it to get the font. And we have a few different errors. It says await expressions are only allowed within async function and at the top levels of modules. So to use await keyword, the function that's calling in should be async function. So I'm going to add async keyword to our p.setup function. And other thing is that we've been using font to store p5.font object, but we are not doing it anymore. So how about we just delete it? I'm going to delete preload function altogether. And this is not p5.font object anymore. So let's delete this comment as well. And now we get another error. Font, the text point is not a function. So I'm gonna delete this as well. Looks good. And let's look at this font object. It's printed on the console. So it's a different object, right? It's not p5.font object anymore, but this font object is coming from opentype.js. So it's got a lot of interesting information like number of glyphs, ascender, descender, some metadata about the font, name and copyright information, etc., etc. And what we want to do after loading this opentype.js font, so we want to get font path. And here's how you do it. We use font.getPath, which takes a few parameters, text, x, y, and font size, which is very similar to how we did with p5.js textToPoints method. We have txt variable, we have x and y, and font size. And after we get the path, let's console log it to see how it looks like. And we get an error. Path is not defined. Yes, I need to move up here and define path variable. And now we get path. If you look inside, path object has commands field and a few other things like fill, stroke, stroke width. But we are right now interested in this command. When you open it, it's an array of objects, which has type, x, and y. Or sometimes it has x1, y1, x2, y2, and xy as well. So it depends on which type of command we are looking at. So type M is move to. So it'll move to x and y location. And C, type C is to draw cubic Bezier curve. So it's got a few more extra parameters. And L is line to, drawing a line from the previous point to this x and y point. And Z command is to finish drawing this path and start another one using move to command. So this is better than textToPoints because now we have M and Z, which defines the start and end of each path. So we'll be using this data to draw a clean outline. Let's come back to our code. And at the very end of our sketch, outside of sketch function, I'm pasting a function code. This is what I wrote in advance. So this will take a p5 object and a path object coming from opentype.js. And depending on which command is being used, it will call an appropriate p5 command to draw. So in the case of M, it will begin a new shape and draw a vertex. In L, we'll draw just another vertex. And in case of C, draws a Bezier vertex. And we don't see it here, but OpenType also has another command called Q, which is to draw quadratic Bezier curve. So we use quadratic vertex method. And when command type is Z, we will just end shape and close it. So by using this function, we can sort of convert opentype.js path object to P5 drawing. So instead of using this, only using vertex functions from before, we just simply use draw opentype path function and pass p object, p5 object, and the path object, which comes from font.getPath here. And now we can see clean outline separated by each path command, series of path commands. We're making a good progress. And the next step is to sample this path data to a series of points. opentype.js library doesn't have a way to sample their path. So we'll have to install another library. The one that I'll be using here is called g.js. So let's open up another terminal window and npm i g.js. And once it's installed, let's come back to our code, move up to the top, and import g from g.js. And let's move down to setup function. We'll convert opentype.js path object to g.js path object. So I'm just going to call it gpath so that it is different from the variable that we've been already using, path, and then new g.path to create a new g.js path object. And what do we pass in here? We pass a series of commands. The commands that g.path requires has the same data structure as opentype.js path command. So what we pass in here is path.commands. And then we'll have to define gpath as well up at the top. And then we're not using PTS array anymore. This is from p5.js textToPoints. So delete it, save it, and we get an error. Cannot read properties of undefined reading commands. And I've noticed that even though we have set our function properly using async and await command, I think p5 doesn't properly support async await internally. So what I had to do to make sure that font object is ready by the time you're using it is to check if font object is ready. If not, just return and don't run any of the drawing commands. And once you've done it, now we can see our sketch back. So this line is to make sure font is ready by draw calls. So we have a gpath object now. So let's just console log it, gpath. When you open it in console, we got a gpath object, which is pretty much the same fields as we had before with opentype.js path object, right? We have commands, we have field stroke, stroke width, we have field stroke, stroke width. So when you just print it on the console, it looks like these two objects are sort of the same type of object, but the prototype is different. What method it supports, that's quite different. So opentype path object has a prototype, these types of methods, but when you look at gpath, meaning g.js path object, prototype has a lot more methods that we can use. And the one we'll be using is this one, resample by length, so that we can resample this path to a series of points. So that's what we'll do next. So coming back to our code, after we create gpath object, we will resample. So g.resample by length, which takes two parameters. First is path object, gpath, and then the distance between each point. So if you put in some low value, it'll be very dense. So point will be created every 2 pixels or every 4 pixels. So let's just start with 10. Then I will store that to a variable called resampled, which I will create at the top like so. And also before we use it, let's console log it. So resample is another path object. Open it up and we have commands again, but there's a difference here. Before we resample this gpath object, when you look at it, it's got 66 commands. using M, C, L, Z, M, C, L, Z, etc., etc. But the one that we just resampled has a lot more data in the commands array, 330. And when you look at the type, there's M, there's L, and there's Z. But that's it. There's no Bezier curve like C or Q. It's just a bunch of simple points, M, L, and Z are the only commands. So because we resampled it. So these are just series of simple XY points, but we can still tell when each path starts by looking at M command. And we know exactly when this path, so in this case, first one T, ends by looking for a command type Z. But it is still in this one-dimensional array. I think for later, when you start drawing and animating, it'll be more helpful to convert this one-dimensional array into two-dimensional array. So each subpath will be in its own array. So T is an array, Y is an array. P actually has two paths, this outer one and inside counter shape. So each one will be its own array, etc. And to do that, I've written this function, which I just pasted in here, which transform path data that has this format, single array with object that has type X and Y, to group of points, so two-dimensional array. And we don't need type anymore because it's just a bunch of points. There's no complex Bezier curve. So we don't need type. You can just simply an array of X, Y. We don't even need to use an object, just a number array. And the code looks a bit complex if you're not used to ES6 array methods like reduce. But what it basically does is when it finds command type M, it will create a new subarray. And when it's not Z, it will pass to that newly created subarray current command.x, current command.y as a simple number array. And we just ignore Z because Z doesn't have any X and Y data. It just indicates that's the end of a path. So we are transforming resample.commands data to a simple number array. And we can see by console logging this resampled groups, there's an error because I haven't defined resample.groups. So let me move up to the top, resampled groups as an empty array first. And when we console log it, now we have 6 elements within this resampled groups array, meaning each array contains a single path. The why is it 6? We have only 4 letters. That's because of these counter shapes in P and E. So these need to be handled separately. So 1, 2, outer one 3, inner one 4, outer E 5, inner E 6. So that's why there are 6 arrays in resampled groups. And in each group will be just simple XY, XY coordinates. By transforming the data this way, it'll be much easier to use it in later stages. Then let's use this data to draw points. I'm going to comment out, draw opentype path, resampled groups that for each, meaning for each group, each group has a bunch of points in it. So we need to iterate over these points as well. So group that for each, inside each group, we have individual point. And we want to use this point to draw ellipse first. So pt.x, no, it's not x anymore, right? Because we converted object to just simple number array. So x coordinate is within pt at index of 0, and y is in pt index of 1. And just 8, 8. If I do that, then now we have successfully converted, transformed each path into its own array, and then resampled and draw as ellipses. And to test that we do have control over each path, I will draw each ellipse with different color, or I should rather say each path with different color. So p.stroke, I will use an index. Which one should I use? Do I use I index or do I use J index? I should use I index for each group because I represent each group. So if I just use just a random number, I times 30, 200, 200 or something like that, you can kind of tell, it's hard to tell. Let me update my color mode of P5. P.color mode, I will use HSB and just change the range to 0 to 1. And then come back down. So this is not RGB anymore, but HSB with the maximum value of 1. So if I just say I times 0.1 for H, hue, and saturation and brightness all maximum. Oops, sorry about that. That's because now background 50 is like full white. I want this to be black. And stroke value of maximum 1. And now we can see that each path can have its own color. So I'm using just color or hue, but the important thing here is that we now have a control over each group. So if you want, you can move them, animate them, rotate them individually, or use different stroke weight or anything else you want to do per group. And we also have J index, so you can do something different per point or per vertex as well. And now we know that groups are working. Let's change ellipse to using path. So for each group, I will begin a new shape and end shape and close it. And instead of ellipse, I use vertex, and make sure you remove size parameters. And stroke can move up one level. Individual point doesn't have to use different stroke color. And if I save it, then we get this. You see how corners are not quite smooth enough? That's because how we resampled. When you use g.resample by length, I use every 10 pixel. So if you use a lower value, something like 4, it'll be much denser and higher resolution like this. Of course, if you use too low value with very long text, then that's a lot of data to handle, so animation may become quite slow. Now, how do we animate it? Animate this line growing. Right now, we are connecting every single point using vertex. But instead of doing that, if we sort of limit how many points should be included in this path and then keep increasing that maximum number of points to draw, then we can basically animate the path growing. So to control the max point to draw, I need to change this for loop structure a little bit. So let me rewrite this for loop. For let j equals 0, j until, for now, let's just say 20, j++. And the inside, that's the same p.vertex. And we don't have a pt object, so pt will be just getting group at j index. Save it. Then we get something. So it's now only drawing 20 points. And this line here is to close it. So if I remove it, you only get 20 points. And as I'm increasing this value, say to 80, we get more of the paths being drawn. So if we animate this value, we can animate the path growing. But we can't just use this hard-coded value like 20 or 80 because we don't know how many points are in each path. So this T may have 300 points, but this O may have only 200 points or something like that. So this will need to be converted to a variable. So I will create a new variable called num points to draw. How many points should we be drawing per group? And for now, let's just set it to group.length, meaning I will draw every single point in each group. And then use that value to determine this max point. Then we are now drawing every single point in each group. There is a little bit of gap. That's because of end shape now doesn't have p.close. So if you include it, it's done. But this p.close parameter should only be included if we are sort of finishing up drawing every single point. But if we are in the middle of drawing this path, this should not be included because see what happens. If I only draw half the number of points in each group, this is what happens. Then how do we decide when to include, when not to include? Well, we can maybe simply use an if statement. If num points to draw is same as each group, the length, then we add p.close. If not, we don't, like that. So back to drawing every single point. And now it's closed and there's no more any gap at the end. And moving on to animation. How do we control animation? The way I like to do is by normalize a range of 0 and 1. So 0 meaning animation is just starting and 1 meaning it's at the end of that animation. That's how I usually like to do my animation. And I will define const t that goes from 0 to 1. And how do we animate this t value from 0 to 1? In my previous videos, I use a separate anim class to do time-based animation. I think that approach will be better. But in this video, I don't want to take too much time going into that. So I'll just use frame count, simple frame count to control our animation. So the p.frameCount. So frame count variable increases by 1 each frame. And then I will divide it by duration of animation, the number of frames. So let me move up to the top and define duration. How many frames? Let's just say 200 frames in frames. So at first it'll be 0. And then at frame 200, the t will be 1. So basically I converted frame count to the range of 0, between 0 and 1. But frame count will keep increasing beyond duration. So I'm going to use math.min. So the t will always be between 0 and 1. It doesn't go beyond 1. And to our loop number of points to draw, I will multiply t to the group length. And then group length is always fixed, but t is increasing from 0 to 1. So it will effectively animate number of points to draw from 0, when t is 0, to group.length, the total number of points. And this will return float value. So let me just floor it to integer just to be on the safe side. And then we can see this animating. And in this case, each group is being animated all at the same time because we're using t, same t value for all the groups. But what if I want to animate sequentially? So t will be animated first and then y, then to the p, etc. Then we need a way to control this t per group. So I'm introducing a new variable. So this code makes sure that each group t is within the range of 0 and 1. And when it's not in their turn to animate, instead of being negative range, it'll always be 0. And when a group ends its animation, it doesn't go beyond 1, but stays at 1. And now, for number of points to draw, instead of using t, we use instead group t. And there you go. If it's too fast, just come up to the top and change the duration, let's say 300 frames. And I want to also make it a bit thicker. So now we can control if you want to animate all at the same time, use global t value. Or if you want to animate sequentially, use group t value. And I like its flexibility, just having single t value that goes from 0 to 1 in that normalized range. Then we can transform this value however we want. Whether you want to use group t, or maybe, I don't know, maybe apply some easing. Although easing alone won't look that nice because of how we resample the points. But I mean, there are so many things you can do. Or if you just want to see how it looks like at t value of 0.7, and this is how it looks, or 0.2 in the middle, or animate backwards, forward and backward, or loop it. All you need to do is just control this t value between 0 and 1. So I like its flexibility. And that's how I like to animate programmatically in most of my animation. And that's the end of today's video. If you like this video, please like and subscribe, and I will see you in the next video.